Hello, hi, good morning my dear students. Again we are in the second video of some basic concepts of chemistry. So in the last we have discussed some basic concepts of chemistry, and here we are discussing the most familiar, you are very much familiar about the today's concept, that is SI unit. SI unit. What is this SI unit? Here SI unit is nothing but, SI is nothing but international system of unit. So for some of the units, some of the measured quantities, we are representing the standard units, so that throughout the universe we are using the same kind. For example, we are saying to the time t is the time we are measuring in second, not in minute, not in hours. Compulsory it is in seconds. So SI unit of the time is second. Similarly, for the temperature it is, we are having a degree Celsius also, Fahrenheit also, and Kelvin also. But moreover, we see that degree Celsius is familiar, but the SI unit of temperature is Kelvin, but not the Celsius. So such kind of some still more the new concepts are discussing in the SI unit. Just we will move towards that. Okay. Look here, students. The SI unit of physical quantity. So in the physical quantity, we are observing totally 7 fundamental units, 3 plus 3, 6 and 7. These are the 7 physical quantities, and we are going to look at the SI unit of this concept. Among these 7, you are familiar about 2 or 3. Look here, while in the notes I have written 4 columns, here I have written only 2. So it means the symbol of quantity symbol I have written, the name I have not written intentionally. Why? Because look here, L is nothing but length. L is nothing but length. The length symbol we are representing as L. L means length. Length of this board is how much? It may be 1 meter or 1.5 meter or 2 meter. So we are measuring the length in the symbol of meter, not in the centimeter, not in the kilometer, not in the dm cube. No, never. The SI unit of the length is meter. Meter symbol is M. Meter. The name of M is meter, but meter symbol is M. Whereas here, M is the symbol of mass. Mass is nothing but, what is the mass of this choppies? How much weight it is there? But we are not using the word weight. Weight is not the accurate word. To know this weightage, but not the weight. To know its quantity, how much it is there, we are using the word mass. Mass is nothing but weight only, but it is having some different meaning of mass and weight. We will come to know soon in this video only. So here mass, it's having the symbol M. That mass can be calculated by, the weight can be calculated in gram, milligram, kilo, kg, ton, quintal. But the standard SI unit for measuring that weight is kg. To measure that word, mass can be calculated. The SI unit of mass is kg, kilogram. The kilogram is represented as kg. Similarly, T is the time. T is time. The SI unit of time is second. You have to write the small word as, you are not supposed to write SEC, sec. No, never. It's a wrong expression. Most of you have in the high school, you are writing SEC. It's a wrong expression. For the time, you have to write the SI unit second, only small letter. Yes. Next one is I. I is nothing but it is the current. The I is the symbol of current. The SI unit of current is ampere. Capital A. SI unit of current is ampere. So look here. The current is having the SI unit ampere. The current is having the SI unit ampere. The temperature symbol is T, and the SI unit of temperature is capital K. Capital K is the Kelvin. The SI unit of the temperature is Kelvin. Where N is the mole, means number of moles. Here, it's calculation of number of molecules. Molecule can be measured by the symbol N. N is nothing but number of molecules, N. And SI unit to measure the molecule is mole. In the bridge course I said you, 1 mole of the hydrogen, 2 mole of the hydrogen, 2H2, 1H2, 3H2. So N is nothing but number of moles. The SI unit is mole. Whereas I, capital I and small v subscript, it indicates the luminous intensity. intensity means brightness of some substance. We are not using it in the further, but you should remember it's important for 1 mass. What is the SI unit of luminous intensity? Luminous intensity SI unit is candela, capital C, small d, capital C, small d. It's the SI unit of luminous intensity, and we are say that CD is called as candela, but symbolically means CD. Only 2 more, but we are writing as MOL. MOL is a Kelvin, ampere, second, kilogram, meter. It's a length, mass, and time, current, temperature, moles, number of molecules, luminous intensity. This is about the physical quantities. So look here, you should know the difference between mass and the weight. As said, mass is represented as M and SI unit of mass is Hg. Here, mass and weight. What is the difference between mass and weight? Look here, to ask your friends what is weight we are calling, but we are not saying what is the mass. Why means, if I want to say the weightage of this one, so I am calling this as a weight. Weight is nothing but what? Weight is a force. It is a force exerted by the gravity. Exerted by the gravity means weight is depends on the gravity. So think that I am a person, any of the person in the earth. So I am saying that my weight is 60 kg. 60 kg is nothing but what? No doubt we are saying the SI unit for the weight also kg only. So here my weight is 60 kg. It means that it is a force. It's a force. I am moving towards the earth. Why? Because earth power, that is gravitation, is taking my energy. The force is exerting. It's attracting me. Attracting as like a particles. It's attracting like a any of the matter. So it attracts everything. So how much force of this gravity exerting any of the matter? That quantity is called as weight. So weight is nothing but it is a force exerted by the gravity or gravitation. So whenever we are calling the weight is nothing but it's a force. How much of the gravitational force exerting on us, that measured quantity itself is called as weight. So comparing to the mass is a quantity or the actual amount of the matter. Actual amount of the matter, it do not depends on the gravity. It not depends on the gravity, not depends, not gravity is nothing but not depends on the gravity. So it means that if I take the mass of this substance, means it is not depends on the gravity. We are not calculating this quantity based on the gravitation. It's only mass. If I am taking the mass, means the mass of this duster will remain same throughout the universe. Throughout the universe, whenever you go, India, apart from India, America, New Zealand, wherever you go, apart from the one country to other country, apart from one continent to another, ಈಗ ನಾವು ಖಂಡಗಳಂತ ಹೇಳ್ತೇವೆ, ಒಂದು ಸಮುದ್ರದ ಇನ್ನೊಂದು ಸಮುದ್ರಕ್ಕೆ ಬೇರೆ ಎಲ್ಲೆದ್ರೂ ಹೋಗ್ರಿ ವಿಶ್ವ ತುಂಬ ಮಾಸದ ವೇಟು ಕಾನ್ಸ್ಟೆಂಟ್ ಒಂದೇ ಆಗಿರುತ್ತೆ. ಮಾಸದ ವೇಟ್ ಸೇಮೇ ಇರ್ತದೆ, ಎಲ್ಲಿ ಹೋದ್ರೂ ಮಾಸ್ ವೇಟ್ ಒಂದೇ. ಅದಕ್ಕೋಸ್ಕರ ನಾವೇನು ಮಾಡ್ತೀವಿ, ವ್ಯಾರ್ ಸೇ ಮಾಸ್ ಆಫ್ ದ ಹೈಡ್ರೋಜನ್, ಮಾಸ್ ಆಫ್ ದ ಕಾರ್ಬನ್, ಮಾಸ್ ಆಫ್ ದ ಆಕ್ಸಿಜನ್, ಮಾಸ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೀಸಿಯಂ ಅಂತ ತಗೊಂತೀವಿ. ವಿ ಆರ್ ಟೇಕಿಂಗ್ ದ ಮಾಸ್ ಆಫ್ ದ ಆಟಮ್ಸ್. I hope you are remembering atomic mass we are calling, but we are not saying the atomic weight. No, wrong. Atomic mass weight because the mass of the carbon, hydrogen, oxygen, any of the elements, they are taken as a unique throughout the world. That's why we are using the mass instead of weight. If I am having the 60 kg, it is 60 kg in some place. If I move from one place to another, means one country to another, very far away from one end to the another end of earth, then my weight will be varies. Why? Because as the gravitation force changes, the weight is also changes. Means weight is a force exerted by gravity and it is variable and it depends on the gravity. Mass is the actual amount of the substance, actual amount of the substance, and it is not depends on the gravity and it is constant throughout the universe. Mass is not variable, whereas weight is variable. I hope now onwards you can able to differentiate what is weight and mass. Is it okay? So prefix, here prefix is nothing but the word which is used before the term. It is called as prefix. So I hope in the English you are familiar about the prefix and suffix. Suffix is nothing but the word which is placed at the end. Prefix is nothing but the substance or the part which is placed before, it's called as prefix. So here in our syllabus we are having prefix for the SI symbol. Here prefix is nothing but to write some of the component. kg, here kg is nothing but kilogram, whereas kilo is having the word K, capital K. K is nothing but 1000, but 1000 it is having a value 10 raised to 3. 10 raised to 3 is called as kilo. Similarly, you are finding about nanometer. Nano is nothing but 10 raised to minus 9, and it is meter as it is. 10 raised to minus 9 is called as nano. So like that, we are having some of the prefix which are used. Instead of writing this 10 raised to minus 9, we are using nanometer. Instead of writing 10 raised to 3, 100 gram, 1000 gram, can be written as 1000 is nothing but kilogram, that is kg. Kg is nothing but kilogram. The value of kilo is 1000. That's why we are writing the 10 raised to 3 is nothing but kilo. Such kind of words are called as prefix. So you have to remember these words. It will help you to write that in a mathematical expression. In some of the problems you are going to use, not only in first PUC, in higher education also you are using such kinds. So these are important. Just for 1 mark they may ask you write the proper prefix for the symbolic representation. If they give some of the values, it is possible to write the prefixes. You just remember those values and its symbol also. Okay, my dear students, in the SI unit we have around 7 fundamental units in the physical quantity, that is length, mass, time, temperature, luminous intensity and moles, like that. So here we are not discussing all the SI units in detail. Some of the SI units are discussed here because it will be asked 1 or 2 marks interviews applied questions. So that among those I am discussing, one is temperature, another one is density. Actually we are not discussing density there. So here you are having density. So look at this one. Density is nothing but density. Whenever we use the word density, you should remember the formula. Density is defined as it is the ratio of mass divided by volume. The ratio of mass divided by volume. So here, you know mass is nothing but it is a weightage which is not a changes from one place to another place. It is a constant, that is called as mass. So mass, volume is nothing but it is a 3-dimensional structure along x-axis, y-axis and z-axis. We can say, if I say what is the volume of this room is asked, means you can able to say volume is nothing but you have to calculate the length, breadth and height. Together we are calculating, that is as a volume. It means in the 3 dimensions. This is x-axis, this is y-axis and this is z-axis. If it is centimeter, we are taking centimeter into centimeter into centimeter. Totally it is centimeter cube. If we are taking in the form of meter into meter into meter, totally meter into meter into meter. The into multiplication of this is m cube. So it means, so for your kind information, the length of x-axis, length of y, length of z, which one we are using SI unit, whether centimeter or meter. It is SI unit of length is meter. Therefore, instead of taking centimeter cube, we have to take the, whenever we say volume is having the SI unit meter cube. The SI unit of volume is meter cube. Similarly, mass is having the SI unit. What is the SI unit of mass? Tell me. SI unit of mass is kg. SI unit of volume is meter cube. Therefore, if they ask the density is nothing but it is the ratio of mass divided by volume. They never ask you the definition of density, but you should remember density is nothing but mass divided by volume. This is called as density. And they will ask you the definition or SI unit of density. The SI unit of density is kg per meter cube. Kg upon meter cube. That upon we are calling that as kg per meter cube. This is capital K. Kg per meter cube. Or we may write this as kg. This m cube. Here m is plus 3. When this power 3, if it m move to the upside, that plus 3 becomes minus 3. Both are same. Kg per meter cube. So we may say kg per meter cube for this one also. So kg m raised to minus 3. Only for m it is having power minus 3. Here m is having power 3 because it is in the denominator. Below is there. Therefore, we should remember the SI unit of density is kg per meter cube. And similarly, next important is temperature. In this one, they will ask you conversion of temperature. I hope you remember it. Temperature can be measured in 3 units. One is degree Celsius, another one is Kelvin, another rarely uses Fahrenheit. So in the degree Celsius, in our high school level also we are saying what is the temperature. Means commonly we are saying 25 degrees is the room temperature, 27, 30 like that, and the maximum temperature is 41 in Gulbarga like that. We are observing the means they are saying that the temperature in SI unit like degree Celsius, but SI unit is Kelvin. So Kelvin we are using particularly in some of the almost all education field and industrial field we are using the Kelvin. But Fahrenheit can be observed in the medical field. So when the doctors are checking your body temperature, they are using the thermometer. It is having the unit Fahrenheit. I hope you are remembering the body temperature 98, 97 is a common. 96 also it's common. If it is just like 100 Fahrenheit, it means that you are having the very fever. So it means temperature should not exceed more than 26, 27. It's according to the Fahrenheit, but not according to the degree Celsius. So here some of the formulas. These are the formulas used for conversion from Kelvin to the degree Celsius or to convert the degrees to the Fahrenheit. So look here, it's the first one. Degree Fahrenheit can be calculated if you know the degree Celsius. So we know that the human body temperature is 37 degrees Celsius. 37 degrees Celsius. You just put the 37 here. 37 into 9 divided by 5. You do this calculation. To that value, you just add plus 32. You are going to get the value in degree Fahrenheit. Are you getting my point? Similarly, you can take the boiling point of water is 100 degrees Celsius. The boiling point of water is 100 degrees Celsius. You just put the degree Celsius here 100. For example, degree Fahrenheit 9 by 5. Degree Celsius means boiling point of water is 100. I am taking 100 degrees Celsius plus 32. 5 1 its multiplication 9 into 100 divided by 5 plus 30. 5 1 5. 5 2s are 10, 0, 9 2s are 18, remaining 0 as it is, plus 32. So 180 plus 32 becomes 212, I think. So 200, what? 180, 200, 210 and 212 it is degree Fahrenheit. So it means that in the degree Fahrenheit it's a conversion. 100 degrees Celsius is nothing but 212 degree Fahrenheit. So there are some of the famous or frequently asked conversion. One is human body temperature conversion they will be asked, or boiling point of water they will ask. Other than this one, they may ask you, they will give you the degree Celsius value and they will ask you to calculate the convert the 45 degrees Celsius into the Fahrenheit. Means you should be capable to calculate this one. For your kind information, one more. So this time in the PFC, you can able to use the calculator. So whichever you are using the calculator, it should not be a scientific calculator. Normal calculator you can be used even in the examination also. So normal calculator is allowed for your annual exams also. So I hope you may feel very easy to do the calculation, and please don't use the scientific calculator. The calculator which you are using, do practice in that one, so that from first PUC up to the second PUC you have to use the same kind of the calculator, so that you will be feel free to take the calculation very fast. Because in your mathematics and even in physics and chemistry we are using the more important and more number of problems, so it will help you to make fast by using only one kind of the calculator. So better take a citizen which is having large, don't use the small calculator which is foldable. Please don't use that one. Stop that one. You use the little bit big. It is just like a citizen. It's having around 300 to 400 rupees. So that you can get a large number of digital value. The answer will be the accurate. So I prefer you take the little bit larger calculator. It will be very much useful in the second year also. I hope this much is clear. So based on that, try to solve some of the examples which I am giving you right now. So based on that notes whichever I am giving, write in your notebook, and I hope you are clear. You need to write this in the assignment. If you are written in the notes also no problem, but for the notes you do one notebook, and for writing the assignment you can write it in the summary. So convert degree Celsius to degree Fahrenheit. 85 degrees Celsius, 38 degrees Celsius, 52 degrees Celsius. So here on very easy. So conversion of degrees Celsius to the Kelvin. So think that 0 degrees Celsius is nothing but 273.15 Kelvin. Very simple. To convert the degree Celsius into the Kelvin, you just put the addition of 273. If you want to calculate the 37 degrees Celsius, convert this to the Kelvin. Kelvin means you just put K is equal to degrees Celsius. How much it is? 37 degrees Celsius plus to the given degree Celsius, just you have to add the 273.15. 273.15. So by addition of this one, you are going to get the Kelvin value. Kelvin value. Similarly, I am doing this ratio. Convert 100 degrees Celsius to Kelvin. Here, same thing. Kelvin is equal to degree Celsius plus 273.15. So here degree Celsius is nothing but 100 degrees Celsius plus 273.15. Together it is 273 plus 100 is nothing but 373.15 is the Kelvin value. So it means 100 degrees Celsius is equal to 373.15 Kelvin. I hope you are getting. This is very simple concept. You just take these 2 or 3 examples here. So here I have given you the examples. Convert the degree Celsius into the Kelvin. 15 degrees Celsius you have to convert into the Kelvin just by adding 15 plus 273, 37 plus 273, 98 plus 273. Sometimes they may ask you the conversion of Kelvin into the degree Celsius. How means? Just to reverse this equation. If you want to calculate degree Celsius, you just send 273 to the right side. Means K plus becomes minus 273.15. So to the given Kelvin value, just to subtract 273.15, we are going to get the degree Celsius. So this is also important. So these 3 are the important equations in the temperature. It's a frequent question, commonly asked in your annual exam. It will be for 1 month. So conversion of temperature either may from degree Celsius to the Fahrenheit, or degree Celsius to the Kelvin, or Kelvin to the degree Celsius. Only these 3 kind of the conversion will be asked, so that it will be clear for you. I will be sending the notes. So in the next video we will continue the next question. Okay, until have a nice day. If you are having any doubts, ask me or message me. Okay, bye.